Hello, good day. Hello and good day. Today I'm going to share to you on how to tackle questions about the periodicity in paper 2 of advanced level um, Cambridge International Examination. Uh, my name is Agus, and then I'm going to share to you on how to do periodicity. So this question is about the period elements and their compounds. So as you can see on the screen, right? So we have a questions regarding the um, period 3, right? So period 3 is actually from it is actually from sodium, right? It's actually from sodium all the way to um, argon, yeah, all the way to argon. So as you know that atomic radius across period, so when we have a let's say you have sodium here, so sorry, so let me clear. So let's say you have sodium, okay, sodium is actually 11, and then if we write the electronic configurations of sodium, then you'll have 1s2, 2s2, 2p6, and 3s1. So basically, we have 11 electrons in one atom of sodium, while if we compare to magnesium, magnesium has 12, right? 12 electron. So there will be like, as you can see here, there will be like 1s2, 2s2, 2p6, and 3s. Let me change this color, 3s2. So again, if I use to write electronic configurations of aluminum, right? So I got this data from periodic table. Then I will have the same 1s2, 2s2, 2p6, and 3s2, right? 3s2. And then I have another one, is actually 3p1. Okay, so if you see these three atoms, right? So basically, the distinction between these three atoms, sodium has 1 electron in the outer shell, while magnesium has 2 electrons in the outer shell, while aluminum has we have 3 electrons in the outer shell. So this electron, if we write the if I use like orbital to explain this the arrangements of electron in this atom, then basically you can see that I have only 1 electron in the outer shell of sodium, while I have 2 electrons in the outer shell of ma magnesium, so like this. But then I also have three three electrons in the outer shell of aluminium, so like this. So what happens is actually when we add electron on the same shell, then the incoming electron is attracted to nucleus. So this one is attracted to nucleus. So meaning if you only add one electron, if we only add one electron, then the attraction between this electron that you added in the outermost shell of electron, it will be less than the one that you when you add two. Okay, so if you have more electron to be added in the same shell, then it will increase the effective nuclear charge. So effective nuclear charge will be increases. Okay, so meaning if effective nuclear charge increases, meaning that the size Okay, the size of atom will be decreases. So that's why Na has larger atomic radius compared to magnesium, and the smallest of these three examples actually aluminum, because there will be stronger effective nuclear charge between the nucleus with the uh, outermost shell electron. Okay. All right. So now how to organize your answer. Of course, I only use this one just for explanation. So to organize this answer, then basically we can use a good sentence. So the why the atomic radius decreases across period, because uh, adding electron, okay, electron at the same shell. So if we keep on adding electron at the same shell, then it will increase effective nuclear charge. Okay, so as a result, right, increasing of nuclear charge. So as a result, size of atom decreases. Okay. All right. I hope you have a same understanding as I already explained to you. All right. Now, how about the second questions? The first ionization energy of sulfur is lower than phosphorus. Okay, so sulfur has a 16 electron. So if we write the electronic configuration of sulfur, then you'll have 1s2. All right, sorry. Then you'll have where's my? Then you will have, excuse me. Then you'll have 1s2. Okay, 1s2. Sorry for technical report. 1s2, 2s2, 2p6, 3s2, 3p4, right? And then phosphorus is actually 1s2, 2s2, 2p6, 3s2, and 3p3. All right. Now, if you look at the definitions of ionization energy, first ionization energy is actually amount of energy needed to remove one electron from the outer shell electron. Okay, that's why ionization energy is always endothermic reaction. It's actually endothermic, yeah, because we need energy to remove an electron. So before I answer this question, so I just want to address this. I just want to remind you that when you write the equations for first ionization energy, you have to put set symbol, which is gaseous state. So sodium becomes sodium ion plus electron. So basically, this process of removing electron from the outer shell, it requires energy. So it's not that really simple to remove this electron, right? So it's like, for example, I have this, and then I have 2 electrons in the first cell, and then 1, 2, 3, 4, 5, 6, 7, 8, and then I have 1 electron here. Okay, let's say this is actually sodium. So when I wish to remove this electron, this electron, right? So I have to apply specific energy. So this energy is used to weaken the bonding between the valence electron here, right, with the nucleus. So this bond breaks, right? Once this bond breaks, then um, you can actually remove one electron. So the intentions of removing this electron is to make the atom of sodium becomes more stable in the form of Na plus. All right. So back to these questions, right? Back to this question. So how do we explain why sulfur is lower than that of phosphorus? So because basically you have seen we have a 4 electrons. So if I draw p orbital, right? So p orbital, it looks like this. Okay, so 1, 2, 3, 4. But for sulfur, I will have only 3. 1, 2, and 3. So um, as you can see here, the one that I draw is actually electron, right? So this causes spin pair repulsion effect. So once you have spin pair repulsion effect, then these two electrons will repel each other. They will repel each other, then making it easier to remove this electron from the outer shell. So that's why if you encounter this question, so you have to mention that in sulfur you have spin pair repulsion, while in atom of phosphorus you don't have spin pair repulsion. So meaning that the electrons is located in the same in their own respective orbital. So it will decreases repulsion. So if the repulsion effect is so low, then it is not that really easy to remove this electron. Okay, I think that's all for me. If you have any doubt, so you can actually ask me further. Thank you.